Hey all, Satish here. Today let's have a look at pointer structures and unions. So in embedded system, these three are very important. We'll keep using it a lot of times. Even in our general functions, if you have gone through, we had used it, I had not explained it. So today I thought I'll explain in detail about pointers, then structures and unions. So initially when we are studying, these pointers and structures and unions are a bit confusing, and most of us were not able to get it. So today I thought let me practically show you how it works. So pointer basically means it points to the RAM location of the variable. So let me show you. There are variables, like we'll have like variable x, y, z. Three variables are there and these are the values. So in x I can give 1, here I can give 2, and I can give 3. And there is something other than these two things that we use, that is pointers, means the RAM location. Means basically when you declare this variable x, it is only important, this name x is only in the ID, means where we are typing in. Once it goes into the hardware, it is always RAM locations. So let's assume this RAM location for this variable x is for example 1000, this, and this will be 10011. This will be the RAM location, and I am assuming these are unsigned characters. Okay, these are unsigned characters, and this will be the, so it will also skip by one location. I am assuming the processor RAM is 8-bit. Okay, now if it is unsigned integer like a, b and c, I can have any value, 25, so 65,000 on the stretch. So let's assume it starts from, for example, let's say 100. This will not be 100, this will be 102, because unsigned integer takes 2 places in most of the compilers. Again, it's compiler dependent also, but in most of the embedded applications it is generally 16-bit, and this will be 4. For example, float or unsigned long, PQR, this let's assume it starts from 200, this location is 200, this will be 204 and this will be 208, and this location is not something which you will assign, it is assigned by the compiler itself. If it is consecutive, it is allocated consecutively, it's skipped by 4. Again, you will not know, for example, this might not be, the order of memory allocation is something which you cannot decide, it is something which the compiler will decide. For example, if you put it in a structure, then whatever you do, suppose you have unsigned integer here, it will get 20, after 8, 212, and another UI unsigned integer, you will get 214. Okay, that is if it is in a structure, it will get like that. Even normal variables, if you have declared one below the other, there is no guarantee that it will get this location. This can even get 400 and this will get 402. So you cannot decide this. So let me practically show you what's happening. So today let's start with the Renesas ID for a change. So let me comment all these things. So it should not make any difference which ID you are using. The concept of pointers remains the same. Okay, and I'm not going to use the hardware, I'm going to use the inbuilt simulator. So let me declare some local variables inside main. So if you are using global variables, then you don't have to use pointers. I'll tell you why. You can directly load the value into the pointer itself. So let me unsigned character UC, that is how generally I define the variables. If you have followed me, you would have known that. Number 1, comma UC, number 2 UC, let me just name it as sum, I'll do an addition, and for the locations let me make it long. I don't know what is the RAM location, so I'll just keep it long. UC number 1, this will be UL, unsigned long, not mandatory to do it UL, but it's a good practice, because whenever you see the variable, you will know what is the data type. Address unsigned long number 2 address, unsigned long sum address. So here I can put any value. For example, let me load some values into this. Is equal to 25, 33, let me do 75. Okay, sum is something we'll calculate. So now let me take the address of, what is the address of num1. To get the address, you have to put this and sign. Once you put and sign, then the value will not be stored in this variable. This is referring to the RAM location. Okay, that means you are pointing to the RAM location, no more the value of number 1. Similarly, number 2 address. Okay, now let's quickly I've changed the simulator. Okay, let me run the debugger. Syntax. Okay, I will not put a semicolon here. So it's telling that I'm converting pointer into unsigned long. That's okay, we will ignore the error. So let me put number 1, number 2, sum. Let me monitor all the variables. Let me comment this off also. We are not using the LCD here. Build it. We put a breakpoint here. Something is in the user initialize. Oh, there are a lot of things that I am doing here which I don't have the hardware for that. So let me just comment this also. Let me comment it. Comment lines. Let me run it now. Okay, it has come here. So now we have values. So here, let me go step by step. Make it unsigned decimal. I am telling what kind of data so that it will show that. Unsigned decimal. So now this is 20, these are the values. Now I will start loading the address into the address of num1 into this. Let's see what address it gets. So it has got a very big address, 104, that is the address location. So you have given the variable name as you see num1, but on the RAM location of that variable is this one. In this RAM location 25 is stored. So now ideally this should skip by, instead of 89 this should be 90. Let's see how it has done. It is 88, it is going the other way, 87. Okay, hope you are able to understand that. So in num1, num2, num3 the values are there and the addresses of that is this. So now let us do this for unsigned integer also. Let's see what addresses it gets. UI, name it number 3, 4, let me name it sum2, 3, or the four sum2 address, and I can also put this value here. Let's see, is equal to sum is equal to num1 plus num2. Similarly, number 3 I can have a bigger number. Four. Let me just copy this. So it is sum2 is equal to num3 plus num2500 750, easier to know. num3 address 3, address 4, and this. Let's see now. So what we are expecting here is, here the address was skipping by 1, here the address will skip by 2 because unsigned character, so this is unsigned int is 16-bit in this processor. So the location should skip by 2. See, you have got this. Now let me add to watch. And let's also see in what sequence it does. It need not be that after this the remaining 3 get the same, the adjacent locations. Let's see what it does. It is random. It is up to the compiler to do that. And showing notation unsigned decimal, unsigned decimal, unsigned decimal. UI num3 is 196. I don't know why it is 196, 76. I think I didn't build it after once I converted into int. $2,500, 7,000, 10,000. If you see the address location, see it has skipped a few locations, 780, 98. Even though this is, they just declared below that, it gets a completely different address location. 98, 72, 68. Maybe it has given address locations for this also, but it is not mandated that if you assign one below the other, it has to get the consecutive memory locations. Okay, similarly, let's do this exercise for float also. So this exercise just to show you that the float or unsigned long will skip by 4. See here this is skipped by 2, 70, 70, 72. This should skip by 4 because it's a 32-bit. All that is populating, so let me watch this also. And these 3 are notation float, and these 3 are unsigned long. So I'll make 2.5, 7.5. Let me build it once. See, it has got a different memory location. So that is how. So all of these, once you declare, for the ease of writing the code, you have declared the given variable names, but internally it is always RAM locations. So now let's see what happens when you pass it into a function. So let me write a function called as let me write void add unsigned character. Let me add unsigned characters and let me return unsigned character itself. I am just prototyping. You see num a, num b. So let me write the function below. Also I can write the function here itself, because as I am going to call this and this function is above this, it will take it up, else you have to prototype and write the function below. But since the function is there here only, let me write the function here itself. So I will just do it quickly and show you also. Here also let me get the location of these through. So let for returning, you see sum. Let me write f so that you don't get it's internally in the function, because you might get confused because there is something here also. This is inside the function. So now sum is equal to number 1 plus number 2. Before that, let me also get all the locations. To get the location, you have to pass num a and of num a. Let me get the address of sum also. Then I have to return. You see sum f, and let me call this function, to which I will pass num1, num2, and no more add it here, I will add it in the function. Okay, this will call, this is only so generally we normal procedure we prototype the function here and write the function below, but in the sequence of the page what happens is this function is used here, is defined here, and what we are using is below it, so it will work. So let me put a breakpoint, let me compile, let me put a breakpoint here and run. Sum it has not yet calculated, so let me step into that, do this. So now let us see what is this number b and this. We will see also the addresses. All of them are unsigned decimal. So 25, 73, sum has not yet been calculated because I have broken it here. Let me go one more step. So sum it has, so I have added the address, that is not right. I have to add the numbers. Let me build it once again. Breakpoint has come here. Let me jump into the function. So this is outside. Okay, this and this, the variable names have become same. What I have used here and what I have used names. So it is populating there both the places. So let me do one thing. Let me just put it f here and f. Tell it is inside the function. Let me build it. So let me run. So these address locations were, these were the address location. Just let me point it out here. This is the address of num1, address of num2, and address of sum. Okay. So, now when I get into the function, if you see this address, let me, so I renamed it, so it is not showing there. Watch. So, the address are totally different. So, basically what happened was, when you pass that value into this function, only the value got passed. There was a new variable itself declared here. Okay, that is why it has a different location on the RAM. It does not have the same location. So, this is what happens when you are not using a pointer. Basically, inside the function you copy the value into another RAM location. So, you are only passing the value of the variable. So, I think this is very clear to you. So, you have been using this for quite some time. Basically, what is happening is, you are no more using that variable. So, once it pass that variable into this function, only the value gets transferred, and a new location on the RAM is initialized with that value, and when you return sum, that will come and sit in this location, because this function was returning the sum. So, if I have to do this using pointers, so let me do this using pointers once. So, let me do this in pointers. So, here I have to just put star. It means I am no longer passing the value, I am actually passing the address location. Now, you do not have the value, you have the address location. So, to get the value, you have to put star. So, how to get the address, you put and to get the value, you have to put the star. Means if it is a pointer, if it is pointing to an address location, then what will happen, putting star in front of it will give you the value. Okay, now this whatever is coming here is no more a value, it is an address location. So, again you do not have to do this and symbol, because it is already a address location. You can directly take the address location for our display. So, let me do this. I am still returning sum f. What I have to do here is and so now in this function what I did, I passed the value itself. Here I am passing the pointer. When I put and, I will get the address location. That is what we saw here. Hope that is clear. So, inside this function add, you see, let me do pointer. Using pointers, I have passed the address location. So, here I have to I cannot use unsigned character because it is a value. I have to use unsigned character star, means I am no longer getting a value, I am getting a pointer, means RAM location which has a data type unsigned character. It is not a data type of the address location, it is the data type of the data in the address location. That is very important, because the compiler will know that, it will throw up warning. Suppose you are trying to load some long value into this, it will know that it's a type unsigned character, so it will give a warning. Okay, just repeating, once you put star, it basically means you are no longer passing the value, you are passing the address location. So, this UC num a currently has, so the best practice is to write PUC, means it is a pointer to unsigned location. Like naming variables correctly is very important. It is not that it will make functionality, it will make a difference, but it will be very clear for you to understand. Okay. Now, this once I put star or asterisk followed by this number, I will get the value, or else if I just add these two things without the star, the RAM locations will get added. Whatever the value of the RAM location, that is a very big value, those two will get added. Now, to get the address, this is already the address location, I can just put it like this. So, now what we are expecting is the address inside this should be same as this address. Let me build, run it here. So just 104.089, num1, num2 is 88, sum is 87. So the same address location should come, but in this, when it is inside this one. If you see here, 89, 88 and sum it is not a pointer anymore because we have used a local variable that has got a different address. So basically what you have done here is you have passed off the RAM location itself. Okay, hope that was clear. So it locally did not create a variable, it just used the RAM location of the variable. And now why would you do this actually? Instead of doing this, why would you do this? Let's, for example, in some cases where you have to return multiple values. So function, if you have to return, it can only return a single value. If you have to return, like for example, we are doing where we are finding sum and product also, then what we'll have to do is we have to return two things, then this is not possible here. You can again return a structure and do that. But using pointers, what you can do here is you can return multiple, not return, multiple, once you process the function, multiple values can be given back. It's not given back, you give RAM locations of where the sum and the product, and this will write back into that location. So what I will do here is PUC, I will do SU sum f, and generally what I will do is I will pass 0 or 1, means it is a success or failure, just to know that. Let me see, I should have in global or analog. See, I generally return success or failure, telling that whether this function was successfully executed or not. Again, you can find out where it is hash defined, let F12 or something. You can like search for that and find out where it is. So generally all the functions, what I do here is I will tell whether the function executed successfully. For example, let you are doing divide and division by 0 happens, I will return failure, or you are reading from the EEPROM. If the communication does not happen, I will return failure, so that the calling function knows, okay, this function did not execute properly. This is a standard procedure which I follow. And the sum, I cannot do this because this is an address location. If I want to write into the address location, I have to put star. To read from the address location, I had put this star symbol or asterisk symbol. To write into that pointer location, I have to put star. I had passed the address RAM location of num A, num B and the sum. So the sum I will no longer use here, and is not required because I am already getting the address location. I got the address location of A, address location of B, and I got the address location of the sum. To write into the address location, we have to use this star, and to read the value in the address location, I have to use the star. Now let us see what happens. Let me compile. Undeclared success. Let me see where is success. So it is in global.h. I have not called global.h here, so this is the error went away and it has 2. So I have to also pass the address location of the sum. Again, it is returning success or failure, so I will not worry about that. Breakpoint here, just to make sure it is 89, 88 and 87. We get into the function 89, 88 and 87. So I have returned this. So I still continue to get my sum value. The sum is 100. Okay. So just in case, let me comment this, or let me change this num value into, it was 25 and 75, let me make it 125. So the sum should be 200, just for you to convince you that it is loading into this address location. Okay, the sum right now is 100. After execution of this one, it becomes 200. Okay, so that's how we use pointers. So now just to show you that we can return product also. PUC sum, PUC product, product is into. Okay, now I am returning both sum and product. If I was using this return as this, I could not return two values, or I could not update two values. Now I am able to update any number of values. Since I am passing the RAM location, I can directly write into the RAM location. And let me declare a unsigned character, UC product. Again, I have to make sure that the product is not num1 10, and then this is 5. So I have to also pass the product here, because the function I return has stopped here. So the sum is, let me, this data type is, sum should be 10. Right now it will be 100, because initially we had used 25 and 75. So after this, if you see, sum should be 15 and product is 50. Okay, now there is something which you have to be very careful while using pointers. I will show you what it is. So let me do this. The issue is, like, what's happening is, into the function you are actually passing the RAM location. So now there is a security issue, because what will happen, I will show you what it is. So I am only passing num A, I am not passing num B. Pointers, I will do a bit of cheating to get the num B. Let's see what happens here. So here I am not getting num A. So if I do num A plus plus, we have seen that 89, 88 and 87 are the RAM locations. So if I do a plus plus of or minus minus in this case, so let me do, because RAM it is located, so I can reduce the RAM location, means as I do a variable plus 1, if I do, I can also, okay, let me just pass num B here. So num A, so let's not worry about this. Okay, address of num B is, let me write this first. Okay, now this is num A B. So from B I can go to A by incrementing one RAM location. Let's see what happens. So this num B, no, I have to do plus plus, means I have incremented the RAM location by 1, or is equal to num B plus 1 also I can do. Then I will just take num B only once again. So I have num B. Let me not return anything. Let's see what the address location comes for these things. So basically I am trying to, only one value one location I am passing. I am going to increment or decrement that location and trying to get the next variable stored in it. So here I will do, I can just do this. So I have decided to do only num2, and from num2 I am planning to take num1. Let's see what happens. I get in, then I will get into the function. Address f is num2 address is 1088, that is I am passed on num2 88. So now because I have done plus plus and stored that location to this, num1 is 88. See, I have got 88. So now if I have to do a mathematical operation on this, what we generally do here is, let me do only the sum. So I have num_b value I have, then plus plus I can do. So basically what I am trying to do here is, after getting the value, increment the address location. So what will happen is, so whatever this address location was here, 88, it will get the value from 88. After getting the value, post increment to 89. So the pointer has become 89 now, and here I am going to take that. So if you feel that is confusing you, so let me break it down into two things. Then I will increment the pointer, then again sum is take. So after incrementing, we have shown that this 88 becomes 89. Okay, so I should be able to get the value of, or similarly for the product also, let me do that. Before incrementing, let me take this number, then after incrementing, so I have to do plus, and this for incrementing, and for the product it is into num_b. So let's see what happens. So if you just think about it, first I have taken whatever the number value there, whatever number I am getting, which is the second number, storing it into sum and product. Then I have incremented the address location. Since I want to increment the address location, then add it to the previous sum, and also for the product also. Let's see what happens. Undeclared num_b. This is a bit tricky. You can list, I'll just explain to you once again. So I have come here. When I go out, you see it has added and it has done the multiplication also, but I had only passed just one of the numbers. So basically what I did was, here I had passed this RAM location, I incremented the RAM location to get the next variable here. So this is a security issue from the point of view of the function. For in your embedded case, don't forget about the security. Only the issue is, if you use pointer, what happen is, you can write some, if you increment and write some value into that pointer, for accidentally you have incremented it using a for loop or something, it has gone to some other variable pointer, some other variable's location, you can overwrite it. Then what will happen is, in your code you will never be able to debug what was the issue. So you are adding two numbers here. So what happened was, because of you incremented the address location and wrote some value into it, but you had incremented, instead of incrementing 1 times or 2 times, you had incremented 10 times. 10th time means it would have assigned some other variable in that location. Now we have overwritten on that location. Okay, so that is something which you have to be very careful about in pointers. You have to be extremely careful that when you increment the address location, make sure that it is within, it is exactly what you want. If something else happens, you will update some other variable and you will never be able to debug the code. And there is one more thing which I have to tell you is about the arrays. For example, you have unsigned int. Let me do with unsigned int array numbers. Let me have 5 numbers, 1 3 5 7 9. So how, if I want to pass this into a pointer, how do I do that? Let me use this itself, this function itself. So for number 1, what I can do here is, if I pass this directly, you might think that it is, so when you pass an array or a string type, what you pass is generally the pointer. You don't have to do, this is not required. And if you want some pass this, then you will have to use an ampersand to location 0 and 1. This generally, if you don't write this, this generally passes, this will pass the 0th. So when you pass an array or any string, it generally passes the location of the first character. That will be fun. So let's see what happens. So I am expecting sum to be 4 and product to be 3. There is no breakpoint here. Let me restart it. So sum, because of this function, it had done 10 plus 5, that is, no, it had done certain, this 75 plus 25, so it is 100. So sum has become 4, that is 3 plus 1, and the product is become 3. Okay, that is how you point a pointer. And if you want to point the first character, you can do this also. That is 0th location, you can do this also. It will pass the first location of this one. Okay, or else just by doing this also, it will take the first location. And once you have the first location, you can increment to get the second location. Now let's check out the pointers in Microchip. So I'll just copy all the variables which I had used earlier. Now I'll be using the UART to display it. So let me comment this code. This also. So what we had done, I think the first example was, we had done some initializations. Let me copy this. Then we did sum. This function was so if you have come here skipping the Renesas, please go through the Renesas, because I have explained all these things there. I just want to show it to you that it is very similar irrespective of the IDE or the controller which you. Let's do all the 3. Then there is num2, then address of num2 is this. As I told you, ampersand will load the address. It will show you all types of errors here, because we are converting a pointer into an unsigned long. Not errors, warnings. Then we have sum. Then the address of sum. So let me build this. So let me load the code. Okay, and it should come out on the UART driver. The UART driver, if you don't know, you can go and check out of one of our earlier chapters on UART. So you can see the number is 25 and 75, address is 206, 207, and the sum is at 205. Sum is 100, the address location is 205. So 5, 6, 7, that is how it is allocated. Similarly, you can do for the unsigned long also. You should be able to find out. Let me just quickly do that. Unsigned long. So this should have skipped by 2 because unsigned long, unsigned integer is 2 bytes. 16 bits, 2 bytes. See, this location 214, 16 and 11. So here 18, 19, here 14, 15, 16 because it is 16 bits. Let me copy one of this. Copy this. So we have num a. You have to put a star to get the value, and the address is, this is already the address, you can just take that as it is. And num b, to get the value I have to put the star and num b, and the address I'll take it from here. And the address of num b is I'm using that. So let me build it. So just let me delete this so that all the confusion is gone. So now let me write a comment that this is inside the function, a bit confusing there. Just to tell here, I'll write the function name /r/n to the new line. Stop, and I'll start again. So this were the various addresses of the value is 2000. I think I've deleted the wrong function. So I should have deleted this. And in the function, let me put the function name so that you will know that below this is inside the function. Stop, start. So if you see, the address was 221 outside the pointer function where I am adding. Inside the pointer function also the address is 221. This is 222 and this is 220 is the sum. This is the 220. So what here also it works the same way. So it is not related to any ID or anything. This is how pointer works throughout all the. If you take any IDs or any controller, this is how the pointer should work. So now let's quickly check out what are structures. So structure is you can group some variables together, and when inside a structure what will happen is it will get consecutive memory locations. If you remember a previous example, If you have unsigned character, if you have defined unsigned character, see if here you have defined unsigned character, long, int, so many things. So it is not, the compiler might not give consecutive address. For example, this might be not be like 10, 11, 12, 13, 14, 20. It might not give it to you like that. So, but inside a structure, what will happen is the whatever you have declared, all the variables, it will come in consecutive memory locations. So I'll show you what is the advantage if it comes in a consecutive memory location. So at this point of time, two things you have to remember is, one, you can group variables together. While coding, it becomes much more easier. So I'll show you what it is. So let me just quickly let me create a global. The keyword is structure. Then let me do unsigned character UC number 1, number 2, then let me do unsigned integer UI number 1, number 2, then let me do unsigned long also. UL number 1, then let me do a float also, F number 1, and let me name this as structure sample structure. Okay, now this is a function name. So now see what happens is, suppose I want to assign some value into it. I have to call dot UC num1 is equal to 1, then num2 is equal to 2, UI 3, 4, then we have UL number, that is 5, float number is, let me name it, 6. Okay, now what happens, see, if you have numbers like this, you have to remember all the variables. Like if you are defined separate variables, you have to remember all the variables. But if it is a structure, it is grouped together. So once you give this, all these variables inside that will come up. So your coding will become much more organized. So you might, if you have so many variables in a code, like you can remember, for example, UART related. So if you remember our, let me see, delay. So it had a couple of variables here. So I have to remember what this is. If I made a structure called as delay, then when I do delay dot, these two will come up automatically. So the coding becomes very, very easy. Okay, this is one advantage. Then the second advantage is, the second thing, not you can use it for your advantage. The memory locations are always consecutive. So what I mean by that is, let me have a value. Let me do like this. So let me put ampersand and check what happens. Because this long should be able to, it will automatically convert this pointer into character and it should take it up. Let's anyway see. Then we have, this is the value, sorry, I want the value here. Then I want address of this will be and of this one. Similarly, we have number 2. We have the address of that also. Then let's number, F number, you can, instead of, we have a driver for float also. 6 comma 2, let me do 6.6. so let's see what happens. So let me put another line break so that it breaks out. So let's see what happens. So what we are expecting is all these things should get consecutive. For example, if this has got an address 1, this should get 2, this will get 3, it will skip 1 because it's integer, 3, 4, this will get 5, this will get 7, then this unsigned long is 4 bytes. So after 7 this should get 11. So it will give address consecutively. I think it has built. Go to Proteus and run it. Structure example 12, 212, 214, 212. This does not seem to be correct. 212, 214, again 212. Okay, I think I have something wrong in the code. Let me just check. So it is UI number 1. Sorry, it should have been UC, UI, UL and F number. So UC number 1, address of UC number 1, UC number 2, address of UC number 2, UI number 1, unsigned character, unsigned long and F number. Let's try this now. Okay, let's see what it is debugged. So the number 1 is 1, location is 10, 11, unsigned character, only it will skip only 1, then 12 should be 14 because it's an unsigned integer, then it is 16. After this is an unsigned long, so this should have occupied 4 locations, that is why the float is in 220. So you have, now you see that all the memory locations are in sequence. It will get allocated one after the other if you do a structure. Okay, if you define like this, there is no guarantee how it will allocate any addresses. So but if you do a structure, it will come in consecutive location, and it will skip by based on the data type. It will come unsigned character, every alternate it will come. Integer it will skip by 2, long 4, float also 4. Okay, now the same thing what happens if I make it union. What happens is in union all of the variables will get the same location, means 1, 2, 1, UI 1, 2, now UL number and F number, all of them get the same location. So if you see this example, it was incrementing. Here all of them should get 210 itself. That is union. Let me put /r/n here. So let me run this. And you saw that the values were also correctly coming, whatever you are saying, 1, 2, 3, 4, 5, 6 and 6.99. Okay, now you will what will happen is to the same memory location writing 1, 2, 4, 6. So whatever this has been written, all this values will get whatever is written in this memory location. All of them have the same memory location, only thing is the data. So this will get some random values, or only the first 8 bytes of this, whatever it has converted into float hexadecimal, that is a 4 byte, the first byte will come here. Stop. So it should, all of them should be 210 and the values will be weird except for 6.9. See, all of them have been allocated in location 215 itself, and this 6.59 is what is coming here. Okay, so it's very, you will not be able to understand because when it divides 4 bytes, the first byte got this 51. So if I remove this, let's see what happens. So it will be much more clear. I'm just not writing the float value. So all of them got 5. That is because in so 5 in unsigned integer is, if you see hexadecimal, 0x05, and in unsigned integer it is 0x0500, and 0x05 for long it will be 000000. So what happened was, since you wrote 5 was the last thing you have written here, I commented this, so it wrote this into that 215th memory location, and this 05 215, this is 216, 17, 18. Since all of them have the same memory location, this unsigned integer is only mapping to this location. Unsigned character is mapping these locations, and unsigned long is mapping all these locations. Okay, so that is the difference between a structure and union. So there is a lot of advantages. You might think that what is the point of having a union? I'll give you a small example where you can have, where I can show you what is how you can use union to your advantage. For example, let me assume that I am transmitting a packet that starts with a character like this, then it has an ID is for example 01, and the data is 0A, 0B, or let me keep all of them, these to 0, let me 11, 22, 33, 44, this is the data, and let's put a CRC or something like that. CRC is 99, that is a CRC is nothing but a checksum, or I should not call it a CRC. CRC has a definition, let's keep it a checksum. Means based on this value, this location will be filled. So now let's assume that I am either transmitting or receiving a packet like this, and I want to save it. This example let me show in Renesas control, because I can do a debug here, and it will be much easier for you to understand. Okay, let me define a structure here, like let me do it here itself. So what we can do here is, let me do the union. Let me do a structure first. Structure has unsigned character, UC start bit. So this is the start bit, then we will have address, then let's have unsigned character 1 data, data 1, data 2, then let's have a unsigned integer type 99, and let me do 88 and 99 as CRC. Okay, so these two are the CRC. Unsigned int UI CRC, and then I have UC stop bit. Okay, let me name it as S sample packet dot, this ID doesn't fill up like Microchip, so I have to manually copy paste it. This is the start bit, and this is the end bit. If it is filling up, it's a bit more easier to code. Address, start address, let me give 1 or 0x01 in hex if you want to keep, and data is like, what did we do, 11. Okay, let me keep it in binary decimal itself, 11 data 2 is 22, then CRC, let me keep it for example 512 or 1024, 1024, some value, it may not be, it might be another value itself. Then we have the stop bit here. Okay, I think simulator is on. Let me put a breakpoint here. Let me then I can debug this. It comes up as structure and you can see all these value. So as in when I write into it, you can see the values are getting updated here. See, start bit, end bit. Now this has become a structure. So now where can I now let's assume that I want to send it over UART. Then what I have to do is everything I have to, then the start byte, address, data 1, data 2. So data 2 did not get filled here. Data 2, UICRC, UC stop. You have to do all this separately. And if you are also going to save into EEPROM, you have to start storing each variable one by one. So if you use a variable, so let me just do something here. Now this structure has consecutive addresses. As you can see, it is coming one below the address, and the address also you can see what are the addresses that are here, RAM addresses which are allocated. Then let me make a union out of it. Union, and the structure is inside this. So as per definition, union is what all the variables inside that should get the same addresses. So now let me do unsigned UC array. Let me define a size of, for example, let me give it a size of 10 or 20. So now what happens is, or if let's assume that this structure started from the address of FFE14, this array will also get started from the address FFE14. So just to be clear, let me do this. Suppose we had only a union UC bit 1, UC bit 2, then let me keep an integer also, UI bit, sample packet, let me make it U sample packet. So let me build it. Let me just so what I'm just trying to show that you might be confused that how this, you might be expecting this, and this should have the same memory location, but it is not like that. Whatever this variable you have, and this variable you have, and this variable you have, will get the same memory. So this whole thing is considered as a single variable. So the starting of the structure address, the UC bit and this array 0 will be the same. So let me just show it to you once. So let me debug this also once. U sample packet, if you see the address location of UI bit 2, they all have same address location, FFDD4, they have the same address location. Similarly, if you see this array, now this array should have popped up here. Okay, I have not done the union. So what is expected here is this whole thing will be considered as a single variable, as a structure, and the starting address of the structure and this array, these two will have the same memory location. I'll show you once. So let me do a union. I'll just union packet. So it will give error here because what I had done here was sample packet. No, this will be, it is inside a union. So I have to call the union first, then the structure. Okay, let me check if that solved it. Yeah. So now something nice happens. That is our union sample packet, or let me do watch this. See, this has a structure and an array, and both are starting from the same location. Okay, now the sample packet, if I expand, and this array if I expand, that is start bit has an address location of FFDC0, and the array 0th location FFDC0. Then data 1 has a, now it will go like 1, then start address should have not been start address, it have just been address, else it confusing. UC address and UC address. Let me just to make the naming a bit clear, that's all. So UC packet has, U packet is a union which has a structure and an array. So now starting address of the structure is also FFDC0 and starting address of the array is also FFDC0. Once I expand this, you see FFDC0, DC1, DC2, and the array is also having DC0, DC1, DC2. So the array and the structure have the same memory locations. So now how, if I want to transmit the whole packet like start address, data 1, data 2, data 3C, these things, what I can do simply is I can call the UC packet dot, I will call directly the array itself. So I can just transmit the array of 0, or you can put a for loop and transmit the array instead of transmitting this one by one. And similarly, when you are saving, suppose you have 25 bytes of all these things, data, all these things, then you put a for loop and save the array. So what happens is the array will get saved indirectly, all these variables are also being saved. So when you read from the EEPROM, you read into this array, automatically everything will come and set in this. So let me give you a quick demo of what I meant. What I'll do is I'll demo it in Proteus and Microchip. So let us have UC start bit, then UC stop bit. Let me remove all these things. So I'll keep it simple for the demo. UC data 1, data 2, 3, 4, 5. And let me make it a union. Then we have, I'll create a structure inside this. And let me have a array also. Structure also I have to name I'll just name it as packet. So let me initialize it to some standard value and delete all these things. Let me comment it. Dot structure dot start bit is equal to let me curly braces. I have not done the union, so this structure, then I'll do the array. UC array size 10. We have start bit, then we have UC. If you hit dot, you can see all the variables is equal to, just make it UC stop bit. Now let's assume that I have to send this packet over UART. So one way of doing it, I can do UART send character, I think it's capital C. And this is same when you're storing onto the EEPROM also, you will have to do it like this. But actually, this is a slow way of doing it. So just let me just so union structure example, and it is start bit ABCD stop bit. Start bit also and stop bit have the same. Okay, I overrode the stop bit, that is why. Let me put another couple of line breaks. So you can see the packet going A, B, C, D, E, and close the curly brackets. So if you want to take good, make it very simple, I can just transmit this UC array. I'll do this below this itself. For int I is equal to 0, not call the structure, directly call the UC array of I. So let me just put a breakpoint, like line break before this happens. So instead of doing all these things, since it is inside the union, the structure and the array, I can just use the structure. So the result should be the same. See, this also transmitted A, B, C, D, E, this also has transmitted A, B, C, D, E. So one advantage of using structures and unions is the coding becomes easy, because all the relative variables you can group together inside a structure. And by using unions, what will happen is, you can, like, if you have certain amount of data which you want to save it into the memory, or in the example where we transmitted over UART, it is very easy if you are using a union. Hope that was clear.